So good morning to one and all, and very special morning to Dr. Mani Madhukar, the speaker of the session. And I welcome all the participants in this final session of this 5-day STC on security and privacy in computer and communication paradigm. So, participants, as you know, we have Dr. Mani Madhukar with us as a speaker of this final session. So before I hand it over to Dr. Mani Madhukar, I will be happy to brief about our speaker. So it's my great pleasure actually to introduce the speaker of the session, Dr. Mani Madhukar. Dr. Mani Madhukar obtained his PhD degree in computer science and engineering from the University of Virginia, United States. Currently, he is an tech evangelist on cloud, artificial intelligence and machine learning, blockchain, Internet of Things in IBM India Private Limited. Dr. Mani has around 14 years of experience with exposure to both industry and academia. As a part of ecosystem development team at IBM, he works with the ASV startups towards adoption of clouds. His current focus is identifying blockchain-based solution and assist them with Hyperledger and IBM Unix services. Dr. Mani represents IBM in various forums as a speaker panelist on technology areas including cloud, blockchain, IoT, Watson, etc. He is a mentor to blockchain community in Bangalore, supporting community on session blockchain and Hyperledger and IBM Cloud. In his current role in ecosystem development team at IBM, he assists enterprises, startups, incubators in adopting to IBM technologies by conducting and mentoring enablement sessions and platforms. Dr. Mani has authored 3 publications in areas of machine learning, managed recommender system, sentiment analysis in national and international journals. He has also authored a chapter on IBM Watson for healthcare and published by IGI Global. Now I request to Dr. Mani Madhukar, sir, please join us for a great session. Over to you, sir.
Thank you, sir, and good morning, everyone.
Welcome, sir.
Let me start presenting my deck. Okay, I hope my deck is visible to all.
Yes, sir, it is visible.
Okay, great. So before we go further right into blockchain and trying to understand what blockchain as a technology is, because there is a lot of focus around learning new technologies, emerging technologies in academia, which is really very important, right? And I really congratulate everybody who has joined us today, because it's very imperative for us as a part of academic system, be it teachers, be it faculty members, or be it students, to actually learn about the emerging technologies, all the technologies which are current in the market, so that we can really leverage those while these are nascent. The reason is, once the technology matures, that is the adoption matures, the overall scope of the technology and the overall scope of people getting sort of into that new stream gets limited. For example, if you see, right, if you take up our technology, which has been around 20-40 years from now, you'll see a very limited number of people actually joining into that, because there is already a big resource pool already existing in the technological domain. Whereas if you see around the new emerging technology areas, which are the new ones, so you'll find very few people in that domain. So, whosoever is actually working in that domain or technology, irrespective of what experience he or she brings to the table, they are actually joining as a leaders into that technical domain. Why I'm saying so is, somebody who is, so for blockchain, right? There are only very few people who are really very good with this technology right now. Now, when I say few means, a few thousand, right? And we need millions of people in this domain. So anybody who is right now in this segment is poised for a great growth, is poised for a quantum, a jump in their careers compared to somebody, who joins us 5 years from now onwards into blockchain space. Because by that time, the skills market for this technology will get saturated. So it's really important from academia point of view that you adopt to new technologies and you actually take the plunge, you learn them and you work on them, right? So let's get going with this, and let's sort of try and understand where are we, in terms of technology landscape. Now, if you see around, and this is a common slides, next couple of slides, which I actually talk about to everybody. The reason is they really give us a perspective, a good perspective about what is happening around us, because we learn from our environment, we learn from our ecosystem, right? We learn from things which are around us. So if you see around us, right, for last maybe say 5 years or 6 years or some years, right, there is a lot of companies which have groomed up in a very different way. For example, taxis had been there for years altogether, right? But the Olas and Ubers really changed the world like anything. Hotel industry had been there, hospitality industry had been there for a while, but Airbnb has really changed the overall landscape big time, right? Similarly, Alibaba, right? Facebook, we all know, right? They have really disrupted, as we call them, the entire space. And all of this disruption is basically fueled by technologies. Now, these are a few technologies which have really helped in transforming, all these industries, all these business use cases that we just talked about. Now, these two slides are normally shown to everybody. The reason is it basically sets the context of any emerging technology. So whenever you're talking about cloud, whenever you're talking about AR, VR, AI, ML, big data analytics, mobility, blockchain, wherever, these two slides are really important to give you a sort of, a background. Why do we need to do it, right? So if you see there, the technical landscape, almost 63% is, dominated by cloud, right? And then there is another 14%, which is, sort of getting converted through blockchain. That disruption is happening through blockchain. And hence it's really imperative, from your point of view to really understand blockchain and things about that, right? These are just a few numbers, right? So why is blockchain so much important from a global perspective? Now, this industry is really kicking up big time, right? We are expecting almost 10% of the global GDP to be stored in either on a blockchain-based solution or non-blockchain-based solution in some way, by some industry. It can be banking, it can be insurance, it can be manufacturing, it can be healthcare, even for that matter, right? Similarly, we are actually looking at some $3.1 trillion of economy actually being supported by blockchain by 2030, which is like another 9 years from now, 10 years from now, right? And hence this segment is going to be very big in next couple of years. And it's really important that we actually jump into it right now. We understand the technology. We really put this technology to work in some ways, some innovative ways, which can really help businesses do even better, right? And there is a lot of knowledge gap as far as blockchain technology is concerned. These figures are drawn from, a survey of World Economic Forum, from Gartner, a couple of more sources, right? So just to attribute, where I got these from. We'll try to understand blockchain from a use case point of view, and then we will dig into technology, because unless we understand the reason why we need a technology, it will not make sense to us. I'm sure all of us had a breakfast today morning, right? And everyone would have had something good to eat. Somebody would have had a breakfast, somebody would have a paratha, somebody would have something else, right? Poha, or maybe idli, or maybe dosa, or we are having audience from all across the India, so we'll have a number of items being taken up for breakfast this morning. Now, having said that, when you actually ate all that, do you know where that actually food, that ingredients for that food came from? Perhaps no, right? You would not know, that the potato which you were having a paratha from, where was it sourced from, which part of India? When was it actually taken out from the ground, reared from the ground? What temperature was it stored in the cold storage, right? Similarly, the rice flour that you are using for an idli, where did that rice come from? How was that rice stored before it was actually grounded and made into rice flour? You would have no idea about that. It's all a complete black box so far for you, right? So, and because of that, what happens is there is a lot of food-borne illnesses which basically creep into our systems because of consuming stale food, or consuming, food which is actually not good to eat. The quality it's not fresh anymore, and you would not know, right? So that's what is the challenge, right? So this is one problem. Not that the information is not available, there will be information available with the manufacturer. It will be information available with the warehouse guy, what temperature has this potato been stored and all that. But then the point is, for you, for a consumer, it's all like a black box. You would not know about what has happened in the background with the product that you have consumed, right? Similarly, if you actually take another example of a wire transfer, money transfer between international borders, right? A cross-border payment system. What happens here is there are multiple intermediaries sitting in between when you actually transfer money some part of, let's say, from US to India. And the overall process is very opaque. It's not very transparent. It's not very clear, right? And the other bad thing about it is, since being there are multiple intermediaries in between, there is certain amount of transaction fee that you end up paying at different ends. So let's say we are trying to send somebody $1,000. So we will end up paying some 7 to 8% of transaction fee at one end, sending side. Similarly, 7 to 8% of transaction fee towards the receiving side. And the number of days, which actually it's very slow process, so it's not like instantaneous, right? So these are a couple of cons, right, which we can understand from a cross-border payment system. Now, before I get into blockchain and before I actually try to understand and give you the various things, how this is all done, let's try to understand, the evolution of this. Now, as most of you would know, right, blockchain is actually has evolved in a couple of years, right? So it's not something new. That's one part, right? And the other part is, it basically comprises of multiple technologies, right? So, you can have, cryptography, which is a part of it. You will have, internet also as a part of it. You will have distributed systems coming into the part of it, and then so many more technologies which actually are, the factoring elements of blockchain, overall blockchain. So blockchain primarily consists of two data stores. We'll see in due course of time, but in general, it's like you would have a blockchain, which is basically a chain of blocks where blocks are tangled or associated to one another in some way. We use the hash of previous block to encrypt the next block, and so on and so forth. So, and blockchain technology is not just only for for financial industry, for financial transactions. It can be for anything. We'll see a few use cases in due course of time, right? So this is what I was talking to you about. Blockchain actually is bringing together multiple technologies, be it cryptography, be it consensus algorithms, be it shared ledger, distributed systems, be it smart contracts, a lot of things which basically come together and contribute to enabling blockchain-based solutions. So from a research point of view, if you try and see blockchain technology, you'll find multiple components there, right? So cryptography has a lot of scope for research. Similarly, consensus algorithms has a lot of scope for research, right? So we already have something called the PBFT, practical Byzantine fault tolerance method. We have something called as POET, proof of elapsed time. We have something called as simple Byzantine fault tolerance. We have proof of a stake. We have got proof of work. So there are a lot of consensus mechanisms, and there is still scope for a lot more because the amount of effort required into putting a consensus together, right? Then there is this concept of shared ledger, distributed systems, which is central to blockchain solutions, which is again very important, right? So these are a couple of enabling technologies which blockchain you need when you are actually solutioning for blockchain-based application. Now let's try and understand where does blockchain fits and why is blockchain needed and where is blockchain needed, right? So typically, blockchain is for businesses. I'm not saying it's not suitable for other places. It can be used in anywhere. Academia, it can be used for any transaction. But we're talking about transactions, business transactions, right? And when we do that, let's try to get a few terminologies clear, right? Normally, when we do business, right, when we do some transactions, so transactions are never done in isolation. No one person can do a business with oneself, right? So there are multiple people whom you do this, business with, right? Be it buying, selling, be it transfer of assets, being whatever we talk about, right? Now, when you do that, so that means, that network can be either public or a private, means it can be a closed network, like only 5 people will be transacting between each other, or it can be like a public network, right? Where anybody is, welcome to join and do business, right? Similarly, there can be different type of participants. It can not just be customer, it can be a bank, it can be, insurance company, it can be a transport company, it can be anybody, right? Whosoever is actually coming together to facilitate business. They're all participants in some way, right? When you actually do business, you basically, so there is an asset flow over these network, right? Business network. Business network is nothing but connection of all these various participants, right? And this flow of asset is basically governed by some transactions, right? So for example, So when you're doing a degree from certain college or a university, so what you say is you basically adhere to the regulations, bylaws of that particular university, saying that I will study for 4 years to actually get a BTech in computer science or whatever, right? So this is some sort of a rule there, right? Which is governing all the transactions, right? And whatever you do as a part of, that transaction, there is a ledger where you log, where you actually record all these transactions. Ledgers has been there for ages, decades, centuries altogether, right? So let's try and get into the problem scenario. So this is a typical business network, right, where there are multiple participants, A, B, C, D, bank, insurer, regulator, and all that, and they are actually sort of transferring documents between each other, right? So A will be sending some invoice, B might be sending some way bills. Some sort of transaction is basically some sort of document exchange is happening between these guys, which is normally either paper based or maybe some online system, right? Now the problem today is each of these participants maintain their own system of records, okay? And one system of records may not tally or may not be the same as somebody else's system of records. Let's try and understand this carefully. Let's say participant A needs 3 fields to store data. Let's say participant A is sending or actually manufacturing a car, and participant B is buying a car, right? So A is a manufacturer of car, B is a buyer of the car. So for a manufacturer of the car, the database of car, the fields in the database of a car will vary, depending upon, what's the model, what's the engine number, what is the chassis number, what's the seating capacity, what's the engine type, all of that stuff, right? So that is what is relevant from a manufacturer's point of view. But then if you see let's say B is a car dealer. So if you see a car dealer's record, for him, maybe all of this information may not be relevant, right? It may only be a certain piece of this information may be relevant. What? Maybe engine number, chassis number, seating capacity, fuel type may be important for this guy, but then it may not be important that what is the serial number of various components which are put in the car, right? Which is important for A. So that may not be relevant for B, right? Similarly, for bank, even all of this may not be relevant for them. All is relevant is when is the car manufactured, what's the value of the car, what's the seating capacity of the car, who is the car sold to, and so on and so forth. This is one aspect of this, right? Wherein different participants may need different type of data. This is only one part. Second part is when a particular transaction happens, so the current state of transaction for A may differ from what is for B. I'll give you an example. Let's say A paid 20,000 rupees to participant B as an advance for something. Now, in A's ledger, what it will show that A has paid B 20,000 rupees today on 5th of September, 2020. Whereas we see the record of B, that 20,000 rupees will not reflect there. Why? Because it has not come into the B's account, which will come maybe in 2 days, 3 days time and reflect in B's account, right? So banks have a typical settlement time of T+3 normally. So what will happen is, right, so by the time that, bank actually updates B's record, for A, it shows that, I have paid B, whereas B's records show that the money has not come in for B, right? So there is a disparity there. So if you see the transaction today on 5th of September, so A's records show that he has paid, whereas B's records show that he has not received. So there is a disparity, and this is the reason this system is so much vulnerable. And the more the participants, the more system becomes more vulnerable, because it's very inefficient. There is disparate records across different, individual ledgers which each of these participants is holding, and so on. What blockchain brings to the table is, and by the way, I'd like to, tell you here that all the discussion that we are doing today is from a private permissioned blockchain point of view. We are not talking about public permissionless blockchain, right? So I'll again reiterate. We're talking about private permissioned blockchain. That's how the enterprise adoption of blockchain happens, right? So in enterprises, you do not do business anonymously. Public blockchains are more, where anybody can join, they need not disclose their identity, just like the one we have for, cryptocurrencies, right? The Bitcoins and all, where people need not expose their identity and they can still do buying and selling or business using those, right? which is not the case in enterprise segment. In enterprises, you know your customer, you know your client, right, whom you are dealing with. So that's why we're talking about permissioned, private permission, okay, blockchain. So that's what we are talking about today. So let's again go back to the same use case and now try to understand it from a blockchain point of view. What value blockchain brings to the overall system, of things. Now here we are talking about a shared, replicated, permissioned ledger. Okay, what it means is each participant in the network has the same copy of the ledger, which is being shared between everybody, right? And it's being replicated in almost real time. So what it means is A has the same copy of the ledger, B also has the same copy of the ledger, and so on. Whosoever are the participants in this network, they all have the same copy of the ledger. And what happens here is the moment one particular participant wants to write anything on the network, on the ledger, he needs to obtain something called as consensus from other participants in the business network, right? Now, unless all others or few others give that consensus, A cannot write that he has paid 20,000 rupees to B. Now, once the majority or all of them have actually given the consensus, then only A can write to the ledger. And the moment A writes this value to the ledger replicates across all the network participants who has a copy of the ledger. That means in almost same time, B gets his ledger updated where where B can see that 20,000 rupees has been added or credited to his account, right? So that's what, right? So everybody has a same view of truth at all points in time. So there is no disparity, right? There is no disparity whatsoever. This is one point, right? Second is, whatever any participant is doing on this network, there is a natural audit trail to it. So whether, bank has agreed to transfer of 20,000 from A to B, there is a audit trail to it. Whether the auditor has red flagged this transaction, even there that has an audit trail to it. So there is a provenance there, right? Similarly, whatever is recorded, that's actually the final version for everybody, right? So there's a finality to all of this. And most important thing, there is immutability, right? Whatever you write to this ledger is like something like, it's not editable. You can't delete that record from there. You can't add that record from there, right? So whatever is written is sort of written there. You just can't change it, right? So that's what is actually the benefit which blockchain-based solutions bring to the table. Consensus, provenance, immutability, and finality, right? So these are the four, major, benefits when you talk about blockchain-based system. And so just we talked about this, right? So I'll quickly try to take you through a few more slides just to give you an understanding of each of these aspects. So transactions are stored in ledgers, right? So here we're talking about a ledger which is electronic ledger, right? And which is shared across all the network participants and which is immutable. And by the way, whatever business transaction is happening on this network, this is governed by something called as a smart contract or chain code, right? So let's try and understand this again. So whenever A has to sell something to B or B is buying something from A, before doing this buying and selling, there needs to agree on some rules, right? What can be the rules? Look, you will give me 10% as an advance, or the product will be shipped in this quality. This will be shipped in 10 days time. Once the product is received by B, within the next 7 days, B will pay A the remaining amount. These are basically rules and guidelines, regulations, which will basically govern the transaction, right? Now, all of these rules that we are talking about are recorded in a code, are actually encoded in program. That program is basically called as a smart contract or a chain code, okay? Now, this program is more like an autonomous system. Once it is put to, started, once the blockchain system starts, this smart contract executes all the transactions which are encoded, in the form of rules. So smart contract basically derives those, steps from those rules, and based upon that, it keeps on doing things on its own. So there's no human intervention once the, blockchain-based solution is up and running. There can be, new versions, there can be a soft fork, there can be a hard fork, all of that is possible. But then, as far as what governs a business transaction, so there is something called as a smart contract, which is a program, which has all the logic encoded in that, which governs the entire blockchain-based solution, right? So that's what we were talking about, right? Transactions are underpinned by the smart contracts, which are business rules that causes whatever we have to do on the blockchain network. Okay, all that we do on a blockchain-based network, right? Because we're talking about permission networks here, right? So it's basically all these transactions are signed and encrypted, right? So there is something called a certificate authority on a blockchain-based network. It can be a third party, it can be somebody within the network as well who can play the role of a certificate authority, who basically provides for transaction certificates and identity certificates, right? So T-certs, I-certs, right? We will see some of that in more detail in some time. This is what we're talking about, a transaction endorsement or consensus, right? A while back, right? How many people actually, would act with sort of agree to that? What is all that? So that's all taken care of like that. Now, there is an important question, right? Despite everybody having the copy of the entire ledger, A, B, C, D, and whosoever in the business network, they are not able to see the entire ledger because there may be a certain amount of information which B does not want to share with A, or which should not be visible to A, right? So despite that A is having the complete ledger, we use cryptography to control what A can see. So that sort of privacy and confidentiality is actually built into the system. The transaction visibility is on need to know basis, right? So we basically control all of that through cryptography, okay? Now, these are a couple of blockchain solutions which are already live across the globe, right? So be it a trade finance system, be it clearing and settlement system, be it provenance system, be it global trade solution with Maersk, be it something around distributed energy, which is with Tenet and, a couple of more companies. They're all live solutions which are right now, in production across the globe with different organizations. So today we'll talk about a few of these solutions as well. Now, before I go further, I'd like to actually take a pause here. And I'd like to, if there is any questions, you can, sort of unmute, or you can put it on the chat, and we can take those questions before we go further from here. Guys, any questions so far? Okay, any questions, folks? You can unmute yourself, or you can put it on chat, because I guess, that will be a better approach so that you are with me on what we're talking about.
Participants, any question at this moment? Please ask if you have any query.
Okay, if not, then maybe I'll go further and you can park your questions and we'll again come back. I'll again come back to you, for your queries and all.
Sure.
Okay, so let me resume my sharing. Okay, so I hope this is visible now, right?
Yes, sir, it is visible.
Okay, great. So let's go further, right? Let's try and understand. So we're trying, so I was actually telling you the live solutions which are right now in the market and, which are already there, right? So Tradelens is a solution which basically improves global trade efficiency, right? And this solution is really, has been very helpful in terms of facilitating trade on high seas, right? So IBM and Maersk came together, and they have put together this solution. Now, if you see on the right-hand side, there is an infographic which talks about multiple stakeholders: custom brokers, inland transportation, shippers, supply chain systems, trade associations, port authorities, financial institutions like insurance companies, like banks, port community, freight forwarders. There are so many people who are associated or who are part of this, this overall system. Now, it's really very difficult when you have a paper-based system. It takes a lot of time there. So we will see this in due course of time, how blockchain or adoption of blockchain has helped Tradelens in improving the efficiency, right? This is another use case which I will dig into deep, which is IBM Food Trust, which is towards supply chain transparency, right? Which basically sort of helps bringing more transparency to the global food chain, right? How multiple vendors have put fruit products on on blockchain-based network system, and how this has really helped in reducing, people getting sick because of consuming stale food or something like that. So we'll see that. Similarly, WorldWire is another solution which is towards global payments, which really helps in almost real-time payments across the globe, and which has reduced overall 55 to 85% in the overall transaction cost of a particular transaction, right? So we'll try to see those as well. And then there is a solution around a trusted identity, because identity theft is a major problem globally online, right? So Sovereign is a solution which is decentralized, based on decentralized identifiers on a public blockchain, or which basically uses Hyperledger ND technology, okay? And then this is basically a list of different use cases categorized by industry, whether it's financial or public sector or retail, insurance or manufacturing. And this is only indicative. There are hundreds and hundreds of use cases other than this list, which we can talk about, right? But these are typically, ones which have already seen some adoption, low-hanging fruits from a technology adoption point of view, right? Okay. So in India, we are seeing a lot of adoption on a blockchain scenario from a blockchain technology adoption point of view, right? So GNFC is one of the first ones to adopt. This information is pulled out from a Niti Aayog report, where GNFC is using blockchain for providing subsidy to the consumers, right? So fertilizer subsidy to the consumers, okay, which is basically digitized and actually made available through blockchain solution in India. And then there is a solution on land records, which is already live. Then a couple of state governments are already working on bringing taxation on blockchain-based system. Even central government is working on that aspect, right, where they bring up various public-facing things on a blockchain-based system, right, just to improve transparency and reduce the overall response time. So that way, blockchain-based systems are basically being considered. Okay, so let me go further and dig into this one example of Food Trust. Okay, and then maybe after that, I'll try to show you how somebody can leverage blockchain technology in action. Okay, so let me go into this, right? So today, as I was giving you this concept at the start of this discussion, what you ate today, in the morning, you can't be sure about the quality of the product, right, that you had consumed today. Because you would not know where is this food procured, when is this food reared from the ground, whether the food is mislabeled, whether the food is fresh or not fresh. You would not know all of that. That's one of the reasons why one of 10 people actually get sick each other because of foodborne illnesses, and this is even more higher when you talk about from Indian context, right? Similarly, there is a lot of food wastage which happens, because something which we consider which is not eatable may actually be eatable, right? And something which we consume, may be very stale to consume, right? So that sort of knowledge is not there, right? If you talk about from a seafood point of view, right, there's a lot of mislabeling happens, right? People who are, fond of seafood will know that, right? There is a lot of mislabeling happens, which like, where is this fish caught from, whether it's a freshwater fish, whether it's a sea fish, all of that happens, right? So what Food Trust systems brings to the table, right? So right now there are multiple vendors which are onboarded. So Carrefour uses this Food Trust chain system to, provide and trace the quality and origin of chicken, right? Right from production through distribution using a QR code scan. So if you see the box there is a QR code. The moment you scan that, you get an entire history of the product, which is available inside the box, the history of the product and the complete audit trail. When was it reared, right? What temperature was it maintained? When was it stored in cold storage? How was it shipped, right? How much time has it actually taken into shipment? All of that. Similarly, there's another solution for coffee plantations, right? For people to ensure that the coffee beans, where are they sourced from? What's the journey of those beans? Walmart is using, Food Trust for green leafy vegetables, right? To ensure that they are, fresh and they are, sort of free from any problems. Similarly, GSF is using for tracking the freshness of beef, right? Now, this solution isn't very old, right? It's only like 2 years old. but there are almost like 150 plus global diverse company which are already onboarded on this system, including GSF, Joel, Walmart, Nestle, Carrefour, Albertsons, and a lot more, right? Topco and all of them actually. And within a span of 2 years, it's seen almost like 8,000 plus products have been onboarded on the system with 12 million plus transactions. And these numbers are dated, guys. Okay, so this will be even more today as we talk. And almost 40% of the top food retailers, particularly in US and the European market, are on board on this platform, right? And they are trying to do multiple things, right? So with green leafy vegetables, the problem is, which green leafy vegetables are a major source of foodborne illness. Reason is, they are, if not consumed properly, if not cleaned properly, if not transported properly, they actually, they give a reason for so many illnesses, right? Similarly, so this is where it actually all started, right? Where in a Walmart showroom, sometime couple of years, there was this outbreak of E. coli virus because consumption of a, infected cabbage, a cabbage which actually hit the stands. And company took almost like 28 days to identify the exact source of that batch of, of that cabbage. And by the time they could actually identify, even more people, consumed that cabbage and they got ill, and a couple of them even, lost their lives, right? So with Food Trust chain, the recall value is very instantaneous. We'll see that in a while, right? Similarly, Carrefour, as I just talked to you about, GSF, which is Golden Estate Foods, is again one company which is using RFID labeling and IoT sensors to, sort of track the freshness of beef products, right? So IoT sensors basically try to give temperature of the container at all points in time, right? Whether the proper temperature is maintained or not during transit, during storage, and all that. Then this is this coffee, farmer platform, which basically is again about telling where is the coffee beans basically being sourced from, right? What's their journey from farm till the time they're actually roasted and grounded. This is another in Ecuador, which is around SSP, the Sustainable Shrimp Partnership. Again, we talked about seafood and their mislabeling of seafood, right? Nestle is also using it in multiple ways. So let's try to get into more about the solutioning, right? I'll take you through this infographic, right? So if you see there, this is the complete supply chain there, right? Where there are multiple participants, right from the farmer to the manufacturing to the logistics guys to the warehouse and a lot of them, right? And all of them are using this particular system for different things, right? So somebody is using the network for tracking, tracing the food product, right? Somebody else is using it for reliability certification, right? For accountability, whether the product is fresh or not. Somebody is trying to get insights from this supply chain network, right? Let me give you one example, maybe to make these things easier. So let's say somebody has shipped a truckload of apples from someplace in Himachal to a Walmart showroom in Hong Kong. I give this example often in all my hundreds of my talks. So there is a apple orchard owner there in Himachal who is looking to sell his apples to a Walmart showroom in Hong Kong. Now, before they could actually buy and sell with each other, they can't do that directly. So they will need some banking, local banking partners, right, there who will represent them. So let's say this apple grower in Himachal has SBI as his banker. Similarly, this Walmart Singapore has HSBC as their banker. So before these buyer and seller can actually, buy and sell, the banks actually get together. They establish a bank guarantee. They get a letter of credit, which is intended that once the product is shipped, that the bank ensures that the payment will be made, and all that stuff happens, right? All of that happens on a blockchain-based network, right? Now, coming back to the important point which I was telling. So let's say a truckload of apple starts from some place in Himachal, let's say Kinnaur towards Delhi, because from there it will be actually put on a flight to Singapore. Now, the container is air cooled. It's an AC container, so that the temperature inside is maintained at 0 plus minus 2 degree plus minus 5 degrees centigrade, so that the product quality is maintained throughout the transit. Now Walmart actually keeps best quality apples on their stores, because that's why That's how they get premium price, right? Nobody will pay 200 rupees for one apple if the apple is not A1 quality, right? So let's say this apple is A1 quality, which this Himachal guy is selling to Walmart. Now I'll try to spin this use case in some way. So let's say there is this IoT sensor which is embedded on this container, which is sending the temperature every 1 hour back to the blockchain network. On this blockchain network, there is buyer, there is seller, there is bank, there is insurance company, there is this transport guy also who is taking care of the transit right now. Now what happens is during the transit, sometimes the sensor goes off, or sometimes the AC goes off, and the temperature inside the container it starts increasing. The moment it increases beyond a threshold, we just saw plus minus 5 degrees centigrade. So the moment it actually increases plus 5 degrees centigrade, there is actually a trigger which initiates because of the smart contract, right? What does it say? It says that the product has gone, the temperature has gone beyond the threshold, and hence the quality of the product will deteriorate, as the temperature if not controlled. So when that is the case, then insurance company will quickly, issue a renewed policy saying that, they cannot ship, they cannot insure the product for the same value because the quality of the product is now going to deteriorate. This is one aspect. Number two, now Walmart only sells A1 quality apples. By the time these apples actually reach Walmart Singapore, the quality will not remain A1. They will certainly deteriorate in some manner. Now Walmart does not want to keep those products on its shelf. It's a premier, showroom. It only sells to, good quality things, let's say, for example. But then there is a market for A2, A3 type of apples as well, right? There are so many showrooms, there are so many roadside stalls which actually sells those category as well. So every category has a consumer. But the problem is now it is already deteriorated, or it is bound to deteriorate. Walmart does not want to put it on the shelf now, but the product is already in transit. What can we do now? What can happen is, in case there are more than one buyers on this network, right? Now what the seller can do, they can say it can open the product for somebody else to bid. So let's say Walmart does not want to buy the same thing anymore. Maybe if there is a more showroom there in Singapore, or maybe someplace in India, they can buy that. They say, okay, we are good to, we are good with the A2 quality apples, and we can put it on our store. We can sell it through our store. So the point I'm trying to give you is that sort of insights, that sort of real-time insights about the availability of a product, about the movement of the product is being facilitated by blockchain-based systems. Now, why blockchain-based systems? This can be done with a conventional technology as well, right? Typical database, and which can maybe given access to so many people. The confidence comes from the immutability and the consensus and the finality pieces, guys, right? Everybody knows that once the data is written on a blockchain-based ledger, this cannot be tampered with. This is an immutable thing. Nobody can change it. And hence is the confidence that, whatever is basically committed through the system will be as is. Okay. So that's what the Food Trust chain actually utilizes blockchain, and how they are, sort of targeting various pain points. Yeah, so it says previous year, there were almost like 456 food safety recalls globally due to contamination. And each estimated cost is almost like $10 million, right? So let me give you one more statistics here. See this. A typical manual recall would have taken 6 days, 18 hours, and 26 minutes for any product, right? But with a Food Trust chain, it almost takes 2.2 seconds to identify where is a particular batch, where was it sourced from, where is it all right now available, which all stores are selling that batch of product and all, right? So compared to 6 days, 18 hours, and 26 minutes, we are able to, sort of identify a contaminated package within 2.2 seconds. That is what the value blockchain-based system brings to the table, right? So this is just one example, which is for, one pilot test case for mangoes. And this is applicable across, right? Okay, so this is where I basically would like to take you to something called as Hyperledger, which is our open source project under Linux Foundation. So all the demo, all the conversation today, what I'll do even further, I'll focus on Hyperledger Fabric, okay? Now Hyperledger project is an outcome of a hackathon which happened in December 2015, which is right now 250 plus members across the globe. This is January 2020. There are even more people who have joined. And there are multiple categories of companies which are supporting this open source project, right? It's an open source, open standards, open governance project, right? So if you see there, the premier partners are companies like Amex, Airbus, IBM, Intel, Fujitsu, JP Morgan, Accenture, and a lot of them, right? And there are academic associates as well. So if you see there, there is Yale University, there is UCLA, from India, there is Kerala Blockchain Academy is also a part of Hyperledger project there, right? So even you can be a part of it. That's what is the beauty of having an open source, open standard. Anybody, even a faculty or a student or a university can also partner to this project. Okay, so today, Hyperledger as a project has multiple, things there. Hyperledger ND, Hyperledger Iroha, Hyperledger Sawtooth. Today we'll talk about Hyperledger Fabric. Okay, so the current release is 2.0, which came in January 2020, and IBM has something called as IBM Blockchain Platform. We call it as IBP. Okay, so IBP is a blockchain service made available, on IBM Cloud. Okay, now before I go into that, let me tell you one more thing. Blockchain solution typically comprises of two pieces, two components. One is the underlying network that basically connects all these network participants, and two is the smart contract or the chain code which runs on top of it, right? So two major components. One is the underlying network, and second is the smart contract or the chain code which runs on top of it, right? Now, organizations, vendors like IBM, Amazon, AWS, and all, they actually provide blockchain as a service on top of their cloud. Now, what this means is they're offering you the underlying network capacity where you can directly onboard, your clients, your participants, and the vendor will take care of the underlying network complexity. Or be the CA or whatever, right? And what you can quickly do is you can put up your smart contract, which is actually the business logic. You can simply deploy that and you can go ahead with your solutioning. That's what is the most easiest way and most quickest way to adopt to blockchain technology. We will see that in a while, that how do you actually create a blockchain service on IBM Cloud. Now, before I go there, let's try and understand what are the various actors in a blockchain-based solution, right? So as I told earlier, you see at the bottom, there is a blockchain network operator who basically takes care of the underlying network piece. So all those blockchain network participants, which you saw in the infograph, A, B, bank, insurance company, manufacturer, all of that, they need to be connected on one network, right? So that's where this network we're talking about. Second piece is this blockchain developer or the blockchain architect. This is where, you are going to create a skill set, you as an academia, right? So the students that join, the developers that we actually groom, they create the blockchain applications here, right? And then somebody, somebody who's having this experience like me, who puts together the solution, is the blockchain architect. So he's the third actor in this overall system. And then we have these blockchain users. For example, in the use case that we saw of the apple grower, that apple orchard owner or the Walmart owner, they're actually the blockchain users, right? Who are trying to do some transaction on a blockchain-based network. And then there is a membership service, which we talked about as certificate authority, CA, which provides and controls the access of who can do what, who can join the network, right? And there is, of course, a regulator as well, guys, right? So we are talking about onboarding a regulator. I'll give you this example as well, that what's the role of a regulator here. Now, this is pretty new. I'm sure this might even, seem a different concept to you. Now, most of us would have a vehicle, maybe a two-wheeler or a four-wheeler and all, right? Now, normally the insurance of the vehicle is paid on a yearly basis. So I'm sure all of you who have a car or who have a bike would have renewed their, policies, vehicle insurance policies. They would have paid a premium of 1 year, 12 months. Now think about this scenario. In 2020, where there has been for last 4-5 months, there has been no transportation, there's been, the movement has been constrained. That means you have not been able to drive your car or a scooter or a bike on the road, right? That means that the amount of money that you have paid for all these months actually went waste, right? Because your car did not, hit the road. It was not being driven. Your bike was not being driven, but still you ended up paying the insurance for that, thing. Now think about a dynamic insurance policy, and it's not a fiction. This is a reality. This is a solution in Indian market, which is live now. A couple of insurance companies are providing it. So what they say is the moment you bring your car or your bike on the road, you actually can buy a dynamic insurance policy depending upon whether you want to drive it for 1 day or 1 week or 1 month or maybe 2 months, right? Whatsoever period. So let's say if I frequent between India and some place outside, and I stay in India only for 4 months, and let's say my car remains parked for 8 months in my garage. So whenever I come back to India, I can only buy the insurance policy for 4 months. Or let's say because of this pandemic, since the vehicle is parked in the garage and it's not being driven, so whenever I come out of the vehicle, whenever the government allows vehicles to be driven, I bring out this vehicle maybe for 1 day, 2 day, and I buy dynamic insurance policy for this 1 day or 2 day only, which is substantial, cost cutting compared to when I pay a 1 year insurance premium, right? It is phenomenal, right? But then this will not happen, right? No insurance company will actually like to make this happen unless there is a push from a regulator. Okay, so in India, IRDAI is the regulator for insurance companies, right? Unless they push the insurance companies that you should pass on this benefit of a particular technology adoption, companies will not do that. Similarly, there are a lot of cases where the companies do not, honor their commitments when it comes to paying insurances, right? Claiming of insurances, right? So that's where the role of a regulator comes into play, where the regulator mandates that the insurance company should actually honor the commitments that they have made to the clients, the customers, right? So we are not talking about doing away with the regulator, which seems so natural in a blockchain-based solution, because blockchain provides the trust. You don't need to have multiple gatekeepers or regulators on the system, right? But in an enterprise blockchain scenario, we are talking of onboarding a regulator and not leaving them away, okay? So that's what actors in blockchain solution basically talks about. We already talked about this. I'll basically, okay, well, maybe I'll just take 2 minutes about this. We may have a few students on this session, right? So those of you who are trying to adopt blockchain as a technology in terms of learning or development of it, where you should be focusing on, right? Because blockchain is again a huge scenario, right? So what your primary interest as a developer should be on application creation and smart contract writing. So when I say application creation, what I mean is, and I'm talking from a Hyperledger Fabric point of view. So Hyperledger Fabric provides for SDKs in Node.js, in Java, in Golang. Golang is the natural language which Fabric is written into, and Python, right? So you can have application written in one of these languages, and you can write a smart contract based upon that, right? So the focus of a developer should, be within these things. And what they need to do with these, while they create these application or smart contracts, they need to create a system of interaction between the ledger and the traditional data sources, creating of events, integration of various system of records, right? And they should not be bothered about what peers, consensus, and security. Why I'm saying so is because this layer is what is basically provided by the network thing, right? So if you're adopting IBM Blockchain Platform or some other cloud vendor who provides blockchain service, this will be taken care of by them, not by you as a developer, right? Yeah, so this is what I wanted to sort of highlight for those who are interested in development of blockchain-based systems. Let's move on further. So far, when we talked about blockchain, we have just been talking about blockchain, like that. But blockchain from a Fabric point of view consists of two data structures, okay? Two data stores. One is something called as blockchain, and the second is something called as world state, okay? Now, what's these two, what is the difference between the two? Now, world state is something which is a key value pair, but it can be rewritten. It is not immutable. I'll tell you the application of this. Whereas blockchain is like a linked list of blocks where each block has one or more than one transactions is stored in that block. And these blocks are immutable. This chain of blocks is immutable, right? Because hash of one block is used to encrypt the next block, and the hash of next block is used to encrypt the further block, and so on and so forth. So the hash of n-1 block is used to encrypt nth block, and the hash of nth block is used to encrypt n+1 block. And you all know that once you actually tabulate the hash value, even if there is a 1-bit change in the block or in the data, the hash changes. So the moment the hash changes, the entire chain got nullified, right? And hence these blocks cannot be tampered with. So let's move on and understand the world state piece, in a better fashion. So let's say there is a variable called x, okay? X, current value of x is equal to 10. And then there is a process, there is an increment happening on the value of f of x, right? So the process says x is equal to 10, x is equal to x plus 10, x is equal to x plus 5, print x, let's say this, right? So what we are doing is the current value of x is equal to 10. We are incrementing the value of x by 5. So the new value of x will be 15, right? So what will happen is the current value of variable x is stored in world state, which is changeable because you can again change the value of x, you need to change it again, right? But the historical value of x, which was 10 or maybe something else even prior to that, actually gets stored on a blockchain, which is immutable. So you cannot change the historical value of that variable x. Whereas if there is a next iteration of this loop, let's say x is equal to current value is 15. Now we again run this loop, it says x is equal to x plus 5. That means the current value of x is equal to 20. So what will happen is in the world state, the value of x will reflect as 20, and the historical value, which is 15, gets stored into a blockchain as a block there. So that's what is the two ledgers or the two data structures of blockchain about. Okay. I'll basically skip this. This is how the application interacts with the ledger, right? So there is this client application which is developed using some SDK, as I told you, either Java or Golang or Node.js or something, which talks to the smart contract, submits a transaction, right? And then there is an event which gets, because of that transaction, there's an event which gets created, right? And there's an action to that, that event, right? Similarly, when you actually write to a world state, you can have a get, put, or a delete. Whereas when you actually work on a blockchain, it is simply a record statement which basically inserts a block towards the end of the blockchain, right? And then there's a ledger there. So it's just a basic building blocks of a blockchain-based system, how the application, client application SDK works with a blockchain and the world state. We'll see, we'll get into the detail of this as well, right? Okay, this is the architecture of a Hyperledger Fabric. There are primarily three types of nodes, guys: committing peer, endorsing peers, and ordering nodes. See this infograph again, right? So there is a client application which is developed using some SDK, right? The application talks, to endorser. It basically, I'll explain how it means. There is a complete set of slides for that. But if you see at the top, there is a certificate authority, a CA, external CA. It can be external CA, it can be internal CA as well, which provides for the membership service. Okay, this membership service provides for various participants their identity so that they can join the network. This membership service also provides the participants with something called a T-cert, a transaction certificate, which is like a one-time key. Okay, so each time somebody is querying the blockchain ledger or network or trying to write something to the ledger, that key is used. It's a one-time key. It can only be utilized once and the key exhausts after that utilization, right? And so there are a host of other things as well in this infograph. Now let me go further because this can be a bit confusing. Let's try to understand what are these different peers or nodes, which are these, right? So there is one segment of nodes or peers which are called committing nodes. These committing nodes, I'll use nodes and peers interchangeably, so please don't get confused, right? So committing peers basically are the ones which maintain the ledger, okay? These are the ones which commit the transactions and write something to the ledger. Endorsement peers are different nodes or different peers which actually get the transaction for endorsement. They respond by saying, yes, the transaction is good, or no, the transaction is not good, right? Those are endorsing nodes. And third is ordering nodes, okay? Or we also call it as an ordering service. Ordering nodes are the ones which basically are like messaging queue, right? Which sort of create a funnel, wherein all these incoming transactions are sequenced in a manner which can be taken up by the committing and nodes, committing peers to, commit the transaction. So I'll take this. This is a very important piece, that how transactions happen on a blockchain, on a Hyperledger Fabric network. So let me try to give you this. This is, from an understanding point of view, this gives you a complete 360-degree view of how transactions happens on a Fabric environment. So there is this client application, okay? Now the client application sends these endorsement nodes E0, E1, and E2. What is it saying? It's saying, what it is sending? It is sending that the current value of X is equal to 10. I want to change the value of X from 10 to 15. And there is something called as version number. Okay, what is the version number? Version number is the amount of time the variable X value has been changed. So what happens here is, so let's say the version number of X is 2. That means the current change of the variable value X is being changed second time now, okay? So what is the value, what is the client application sending? Client application is sending X is equal to, current value is 10, X is equal to 15 is the proposed value, and version number is equal to 2, means this is the second time that the value of X is being changed. When this information reaches the endorsement nodes refers to one of these smart contracts. So if you see there, E0 is running two smart contracts, A and B. E1 is also running A and B. E2 is also running A and B smart contract. Now, one of these smart contract is basically governing the increment of the variable X. Let's say for the sake of understanding, for the ease of understanding. So what will E0 do? E0 will simulate the transaction based upon the smart contract A. Smart contract A has the business logic that when a variable X should be incremented, how it should be incremented, and all that information is stored here. That business logic is here. So after E0 simulates that application, that transaction, it basically creates a set of read-write data. We call them as RW sets after doing the simulation. And it sends those RW sets back to the client application. So see, E0, E1, and E2, after running the transaction through the smart contract A, have sent the RW sets back to the client application. Okay. The client application bundles all of these together and sends it to the ordering service, right? Now, if you see there, the ordering service is getting input from even lot of other applications also. So ordering service is basically something like a messaging queue. Apache Kafka typically it is, if it's fail-safe ordering service, high availability transactions for high availability, right? So what this messaging or the ordering service does is, ordering service basically passes this transaction into the various committer nodes, right? So in our case, it is P3 and P4. Now see this, P3 is again running a smart contract A and smart contract D. So that means for a corresponding smart contract A for endorsement node E0, there is a corresponding smart contract A which is running on committing node P3, right? So when this transaction comes to P3 will actually collect that transaction and actually validates against the endorsement policy. Okay. It will also check whether the RW, the read-write sets which the endorser had sent, is valid or not. Why will it check that? Let's say the version number which has come along with this transaction is 2, right? But then in the meanwhile, somebody has already changed the value of variable X. So what will happen is the current variable, in the version number will speak as 3, whereas the incoming transaction says version number as 2. That means this transaction is timed out. By the time it actually came to the validating committing node, this transaction is already timed out. Somebody else has already updated the variable X, and hence this transaction is no more valid. So this process also takes care of something called as double spend, in blockchain network, right? So once in case the transaction is valid, the same is committed to the ledger. You see that blue boxes there, blue chain there. Once the transaction is validated, the same is replicated across all the ledgers to all the nodes there. Okay, and once this is there, then we have the updated ledger available with us as the new transaction reflecting into it. So the current value of X is updated to 15, and the historical value of X is equal to 10 has actually gone into the world blockchain, and the world state now reflects X is equal to 15. So this is what a typical transaction, scenario is in a Hyperledger Fabric, right? I was talking about ordering service, right? So ordering service typically is is offered in two modes. One is solo, which is used for development. Another is Kafka, the Apache Kafka one, which is crash tolerant. Okay, so yeah, to communicate between. So see this. Let's say E0 and P3 want to talk to each other. Now, how do they do that? They can do that by creating a channel between E0 and P3. Now, whatever happens between E0 and P3 on this channel is only between E0 and P3, and nobody else is partner to that transaction, that ledger which is available between E0 and P3. Similarly, let's say E0, E1, and E2 and P3 want to talk to each other, so they can again come together and form a channel here. So that is what is the concept of channels, right? Channels isolate transactions on different ledgers, right? And each node can be part of multiple channels, okay? And the scope of ledgers are only private to a channel. They cannot be shared across multiple channels, okay? One peer can be part of multiple channels, right? And they are really helpful in scaling up of the business network, in concurrent execution of performance and increasing the scalability, right? Channels are really instrumental in that. So I will now move on to IBM Blockchain Platform. I'll quickly try to show you a demo there. What is this service about? How do we create it? But before I go into it, I will again like to take a pause here, and I would like to understand if you have any questions around, whatever I have to talk. Any questions, guys? In case you have, you can, unmute yourself and ask a question.
Participants, any question at this moment? Yes, participants. We have anything on chat? Any question, guys?
Okay, let me go further. Then maybe you can, in case you have any further questions, you can park it, and then we'll come back to these later. So what I'm going to do, guys, is I'm actually going to move to my browser. I hope this browser is visible, right, sir?
Right, sir. Right. It is visible.
So, guys, I am actually on IBM Cloud. Okay, this IBM Cloud is offered, free of cost. Anybody can go and create an account and get it started. Particularly for people in academia, there is a program, IBM Academic Initiative, which offers you completely free access, not just to IBM Cloud, but to all hundreds of software which you can download, and a lot of courseware there. I'll come back to that part later on. Right now, I'll focus on IBM Cloud, right? So if you go to the IBM Cloud, there are almost like 180 plus services available on IBM Cloud, right? One of the services that I'm going to give you, or I'm going to show you today, is a blockchain platform, which is available on IBM Cloud. Let me just see, why is the network acting? Okay, so it's just going to load for me. So here there are almost like 180 plus services across different segments, be it machine learning, be it DevOps, be it IoT, be it mobile development, whatever segment you basically talk about, you will find a lot of services which can help you in creating your applications and in different ways. For the sake of brevity today, what I'm going to show you is I've searched for blockchain platform. This service is available on IBM Cloud, and I've clicked on that service. Okay. So once you click on this service, this is where you come on. Okay. Now see this, I am going to spin up an instance of this service, and I want to show you what you get. Now before that, let's try and understand what is written on this page. First thing it says is select a region. So IBM Cloud has 40 plus data centers globally, including one in India, which is in Chennai. These are all enterprise data centers, guys, okay? Now, which offer infrastructure as a service across all these 40 plus data centers. Across all these 40 plus data centers, there are around 6 or 7 data centers which offer platform as a service on top of IBM Cloud. So whatever you see here, it's basically example of platform as a service on IBM Cloud, right? So this platform as a service is hosted across different geographies: Dallas, Sydney, Frankfurt, London, Tokyo, Washington, right? So the choice of data center normally depends upon the location of my client. So if I'm working for an Australian client, maybe I'll create the service on a Sydney data center so that the latency is minimum, right? So which is not the case right now. So I'm just picking up the default, which is Dallas over here. This is the name of the application. Let's say I'll just say it NITJUC, just to give it some reference. And I say, and I have got nothing else to do here. Okay, I'll just say default. By the way, it also gives you the about information, that what is the service, how you can use all of that. This is all available. Okay, so I'm going to show you all that. So it will take some time. So we'll flip between my browser and my my demo, my deck. Okay, so we'll flip between that. Now, what is the process of creating a service? This is what I want to show you, so that somebody who is really keen on starting blockchain development, they can go and they can get started. This is the reason why I want to show you this. So right now, what we are creating, we are trying to create a instance of a IBM blockchain service, IBP, IBM Blockchain Platform, right? So we are trying to create an instance of that service. What this service is going to do, this service is going to create an underlying network for me on which I can onboard my various network participants. Okay, now see this. In order to create a service, these are the 3 steps. One is, this service will create a Kubernetes cluster on which it will host the fabric for me. This will all happen automatically. You don't have to worry about that. I don't know about Kubernetes and all that. I'm just clicking on let's get it started. Now see this. It is telling me that by default, it will create a 4 virtual CPU, 16 GB environment with 1 worker node in 1 zone. This is the typical, developer environment. In case it has to be a production environment, it has to be in multiple zones. There will be multiple worker nodes, and even it might be a different, CPU configuration. Okay, so I'm not changing any parameter, so that you just follow here. Right now, it is checking if I have an existing Kubernetes cluster on IBM Cloud. Okay, so it is so it's checking. Okay, do I have anything here? Let me check if I have some existing cluster here. Okay, let's see this. It says yes, it is there. Now let me click on. It says there is already a service instance associated with this cluster, right? Okay, but then it's okay. I'll go ahead and I'll try to associate with the same cluster. Since when you would be creating your first cluster, it's available for 1 month for free, this cluster. And in case you want it after that, you can again create another cluster after 1 month, So this happens automatically. You don't have to bother about, the process. See, I'm not doing anything, right? This is happening at the back end, right? So what it is trying to create is, it is trying to either create a cluster, or if the cluster is already created, it will actually link that cluster to my service and host an instance of Hyperledger Fabric on top of that. Now it will take a while, guys. Okay, so in the meanwhile, I will actually like to tell you about something more. So IBM offers a program called IBM Academic Initiative, which is this is the URL, ibm.biz/academic. Okay, this is the URL which you can leverage here. This program is particularly aimed at faculty members and students across the globe. It's a global program, and it offers free of cost access to software, courseware, badges, a lot of these stuff. We'll just see that. This is going to take some time, so we'll sort of do something else by the time we come back here. Okay, so this is the academic initiative platform which I'm talking about. This is the one. I hope you can see. This platform provides you content across various technologies. Let me quickly show you what all technologies. Okay. This platform has content on cloud, data science, security, quantum computing, engineering lifecycle management, System Z, power systems, blockchain, and IBM Watson, right? Now, these are only technologies. Let's try to dig into one of these. Let's say you're interested in knowing more about data science. So I'll click on learn more. What does IBM provide, me in data science, right? Let's see there. So if you see there are multiple tabs available here, right? So this is a learning resource, right? And there is a IBM Data Exchange, Data Asset Exchange, which is a online hub for developers and data scientists. It provides a lot of free and open source data sets. Okay, so somebody who is looking for data sets can always come here and look for this. Similarly, somebody who is looking to download software, right? What software? Watson Studio Desktop Edition, iLog CPlex for optimization, SPSS Modeler, Cognos Analytics. All of these software are available for free to be downloaded from here. Okay, you can download it for free. Similarly, there are a lot of courseware available for learning data science, right? So in case you want to learn OpenDS for all, or you want to learn IBM Watson Studio. So I'm just clicking on one of the links to show you how easy it is to learn through here, right? So once you have learned something, how do you let others know that you have learned something, right? So digital badges are the other way of doing that, right? So it provides you access to free digital badges as well, right? So once you have learned the course, you can also obtain digital badges which are offered free of cost from here. I'm just clicking those links to show you, what is available here. So see this. So the moment, okay, this is still loading for me. Okay, I'll just in the meanwhile show you something more. So see this badge here. It's a data science foundation badge. So this badges comes in various flavors, right? Foundation, intermediate, advanced. So depending upon what sort of course you are doing, you can obtain a badge in that, and it's very easy to obtain. It's all on like 3-4 hours of watching a video or doing a quiz, attempting a quiz. And once you do that, you'll be able to get this badge, which you can put on your resumes or on your social media handles. It helps the people know about your skill level. Okay, this is what the badges mean. Similarly, in case you want to learn about, let's say we talked about machine learning, right? So see this, it basically helps you step by step about learning something. See task 1, how do you create a project? See, it gives you a complete step-by-step approach with a snapshot. Step 1, do this. Step 2, do this. Step 3, do this. It even gives you code. Okay, what do you write there? And in case there is a need for data set, it also helps you download the data set. For example, we are doing a churn analysis, so there is a CSV file needed, right? So you can download the CSV file from here. It gives you a complete step-by-step breakdown of how do you learn a particular technology from here. So this is very easy to learn and follow. Okay, so this is what about this academic initiative platform, right? And you have all the contents around quantum, data science, Watson, cloud, and all that. All that you need to do is you need to register with an institutional email ID. You can't access this platform with a Gmail, Hotmail, Yahoo Mail ID. You need a college-provided email ID in order to access it. Faculties can download this courseware and they can use it for teaching the students. Faculties and students can also download various software which are available. They all come with academic licenses. You don't have to bother about that unless they're being used for non-commercial activity. It also has a tab when you can actually explore careers available within IBM. And this is like across for all the technology, right? So I just picked on one. Maybe you can again click on security. So it'll again give you software related to security, which you can download, right? Like QRadar, like I2 Analyst, like that. And there is again a courseware associated with that. So, across different technology segments, there is a lot of content available for learning. Okay, let's see. Let's come back to my original one here, right? Let's see this. It says it has already done that. Now it says launch the IBM Blockchain Platform console. I'm launching the console. I'll just show you what IBM Blockchain Service provides you with once they spin up, the instances spun up. Okay. So, I'll just close this conversation about academic initiative. So you have, a lot of these content available, which are free. A lot of universities are even adding these courses as a credit courses in their regular curriculum learning, because these are offered free of cost. There is no charge associated with that, right? So universities are, using them as 2 credit, 4 credit courses. And since these courses come with some certifications, so students are, also can take exams. Certifications are like exams only, right? But the students can take, and leverage it. Okay. This is still coming up for me. Spinning up the instance. Okay, great. It is coming up. Okay, it's come up now for me. Okay, so this is the IBM blockchain platform, right? Let me quickly get started with this. Now see this, you remember we talked about nodes, right? We talked about committing nodes, we talked about endorsement nodes and all that. So here you can add those peers. Here you can actually add those peers, right? See this? You can create your peers from here, okay? Similarly, you remember we talked about the smart contract, right? Here you can upload the smart contract. I'll show you there are some samples also available, okay? Which you can leverage on, okay? And I was talking to you about the certification authority, right? So here is, you can actually create a certificate authority, and this is the wallet for that, where you can store the various keys which are available to you. You can actually create a MSP definition here. These are the various organizations which you can add to this segment. These are the various, where you can add various users, okay? And you can actually control whether whatever each user is doing. You can enable the client logging, server logging. When do you want the session timeout? All of that can be actually done from here, right? And it comes with the elaborate documentation, guys, right? So in case you are a first-time beginner, please don't get bogged down by the complexity here. The documentation is fairly easy to follow. You can actually, it will help you in hand-holding through the various processes. How do you create a peer? It will do all of that for you. You just have to follow it up step by step. See this? It will give you complete steps here. See, I'll click on this, getting started with blockchain platform for IBM Cloud. Yeah. See, it will show you snapshots, and it will show you how do you create various services. I'm just scrolling down for you so you can get started. Okay, we are right now here. So we already created a cluster. My peer is already up and running on Hyperledger Fabric. It is giving me all that information. How do you create a single zone versus multi-zone capable storage and all that stuff it's been telling me. Okay. So let's say I am deploying it on IBM Cloud. So it will give me the steps of deploying, creating nodes, peers, and all of that stuff here. Okay. Scroll down. It's basically trying to show you what is the peers, what are the various ports it uses, what is the Kubernetes version. This is what we were talking about. Everything it is showing me there. How do you install the policies? How do I create an instance? All of that is actually showing it to me here. Let me go back here, right? This is what my UI there. It also has a wizard, which can help you in getting started. Right? You can simply pick one of these things from here. So in case it also has help about how do you start writing a smart contract using Visual Code. So there's a plugin which is available for VS Code, which you can download and which can get started from a local machine. All of that is available over here. All that you have to do is you just have to get started and get going with this. Okay. Yeah. Let me click on this. So this is my cluster which automatically got created, right? Let me just show it to you over here. So it basically tells, when is the service created, right? What location right now it is hosted on, whether the service status is active or not. I can get all those details from here. Okay, if I go to the connections tab here, it will basically tell me, the various active associations of this blockchain service, if there are any. Similarly, the service credentials will give me, the endpoints and the service credentials which I can write in my code to connect this service with some code, to use the service, to leverage the service. Okay, it's just coming up for me in a while. Okay. Okay, so I'll take a pause here, guys, and then I will go further from here. Any questions so far? Anything that you want to ask?
Yes,
Yes, dear
participant,
participant.
if you have any query, you can ask.
Is there any question on the chat? Because I can't see chat right now.
Yes, sir, there is a question.
Can you please read it out for me?
Yeah, sir. So, sir, Sakshi wants to know what are the open source tools for IoT forensic working with blockchain?
Well, there are multiple, right? But just to begin with, what you can do is you can always go to, one of these security offerings from IBM to help you do that. That's one way to do it. Second way is Hyperledger Fabric is open source. It's open standard and open governance based, right? So you can even leverage that. Besides Hyperledger, you have got Ethereum Alliance, you've got Ripple, you've got Coda, you've got so many other platforms which you can leverage for this particular thing. Okay.
Right, sir. Thank you. Anything else, participants?
Another question there?
You can ask or you can type here in chat section.
Okay, I was basically here on slide or this, get a started page now. You have questions, you can ask me that you want to, or I can just continue with what I have to deliver.
Sir, one more question is there.
Hello.
Two more are there.
Hello, sir.
Yeah, please go ahead.
Yes, please.
Yes, sir. Sir, what are the basic things that you needed for a candidate to learn a blockchain, sir?
Just to get started, look, you need to at least be familiar with coding, right? Coding, particularly in one of those SDKs which are available for Hyperledger Fabric, right? Like Java or Node.js or Golang, one of these. This is one thing. Second is you should be familiar with distributed computing concepts, right? That's really important for you. Third is you should be also familiar with cryptography because that is how you implement, who gets to have access to what. Now, since all of this may be too much to know for a beginner, that's why IBM actually has provided you with a. I'll tell you what. There is something called as code pattern.
Okay.
I'm not sure if you have heard about this earlier, but then let me give it to you. This is the URL developer.ibm.com/patterns. Okay.
Okay.
Now, whatever technology you want to learn under the sun, I'll just sort of reduce the font to make it more availabilities so that it's more. Now, see this. Whatever technology you want to learn, be it analytics, be it blockchain, containers, DevOps, artificial intelligence, data management, data science, deep learning, Java, IoT, anything, microservices, mobile development. There is a long list here, Python, serverless, whatever.
Okay, sir.
So today we are interested in knowing about blockchain. So let me filter it by blockchain.
Okay.
So you see that 364 results were there in all. The moment I filter it by blockchain, I will have some 49 results. See these 49 results? Now, what is this? What is this? I'll try to explain to this.
Okay.
So there is a code pattern on doing analytics. Okay. There is another code pattern for access control, for data collections, for digital asset management, for digital wallet. Let me pick one for which should be understandable to you. Okay, so let's say this. Create a network to support blockchain-enabled crowdfunding. Okay, guys?
Okay, sir.
So I'm just clicking on this code pattern. Now, the moment I click on this code pattern, so code pattern is like a complete end-to-end solution. Okay? So this code pattern will give me a complete project about crowdfunding. And this is the flow of the project. This is the architectural diagram of the various services used in here. And but as a developer, I'm not interested in all of this. I'm interested in the code. So it provides me a free code. It's available on GitHub. The entire code I can fork from here. I can download from here. Not just this much. I also have a complete documentation to how do I deploy or use this code. See this. is step one, deployment using IBP, whether you want to use it locally or you want to use it on cloud, right? So different steps. Let's say I want to use it on IBM cloud. So see, the entire command is given there. Git clone, do this. Once you clone the repository, then you do this other steps. This is what we have just done. We have created an instance of blockchain platform, UCC, remember?
Okay, sir.
Right? So it gives you the complete code. The entire smart code is also given. So if you see at the top there, so the entire, this is the web application. This is the node. This is the chain code. It is provided in this folder there. So the entire code is made available. Not just this much, it also gives you entire steps, what to do. This is the client application. How do you actually bring it? How do you change the manifest.yaml file? What parameters do you change based upon your local machine? How do you deploy it? This is the command to run the WebLift application, right? How do you push it from your local machine to the IBM cloud? This is how the UI will look like, So everything is actually provided here. So this is code pattern. And by the way, there were 49 such code pattern, if you remember, right?
Okay.
So this is just one. This is end-to-end. The complete solution is provided so that you can get your hands dirty with the code. You can play with the code. You can learn more about the development side of it, right? Similarly, if you want to work with the telecom roaming use case, right? How blockchain is being used by telecom companies to record the roaming, user roaming, or maybe fraud detection there. So there is a use case code pattern around that also. 49 use cases means it's a good repository to learn, guys, right? Similarly, if you want to develop an e-voting app, right? See, if you click on this, you'll get an entire code with a step-by-step view of how do you create that. So this is a good starting point, to learn the code, to develop, to understand the intricacies of various things, be it cryptography, be it distributed systems, be it working with SDKs, be it working with various nodes or certificate authority and all that. So this is a good starting point I would recommend to you.
Okay, sir. Sir, I have one more doubt. Whether IBM is providing any online free courses, sir, like that?
None of them. So I just showed you that academic initiative, Ryan, remember?
Can I get that ID, sir? I want to make note of that ID, sir. I observed it, but I didn't make a note of that one.
No, you can just say ibm.biz/academic. This is the URL. This is only a 3-word URL. ibm.biz/academic.
Okay.
Okay. So once you go there, there was a segment. There was a segment on blockchain as well here. I'll go to technology and I'll show you that. So from that you have free courseware available. You have free digital badges also available. Which will help you in learning and obtaining.
Fine, sir. Why am I asking, sir? Most of my students, they are interested to do research, that is in a PhD research they are doing in a blockchain, but without knowing the exact definition for a blockchain, they have registered in that domain. So I want to tell them to learn from the basic. So
see this, there is a book available, Blockchain for Dummies, which can be downloaded from here. Right? There is a courseware also available from development point of view as well as from understanding blockchain essentials point of view as well, right?
Fine,
once you complete the course, in case you're interested in development, you can take up this course. Then there are associated badges also available, which you can do, right?
Okay, fine, sir.
This can be this is all free available, right? You can leverage this platform.
Okay, sir. Thank you so much, sir.
Sir, I have one question.
Yeah, please go ahead.
Actually, I asked the question. I already written that how the blockchain will help to the investigation agency, particularly police, to preserve the evidence, to authenticate the evidence in particularly a crime-related issue. And is there any state basically implemented this blockchain-related this system in India particularly? So please tell me about it, sir.
So Dr. Pathak, so great question. I can help you with a lot of use cases which are being already worked on. In my previous role within IBM, I was working with a lot of startups across the country. So there was one startup that I had worked and nurtured in Bangalore. And this use case that I'm going to talk to you about is on the similar lines. Okay, so in India, there are a lot of these, issues when, somebody stops a vehicle on the roadside and they sort of, they will burgle the vehicle, they will loot or they will misbehave with the people inside the vehicle, right? A lot of cases we keep on hearing, right? Now, so this often happens on highways, right, where people forcibly stop the vehicle and then you can keep on calling a 100 or, the police control number and nobody actually helps you or actually comes to your risk, right? So, so this use case which I'm talking is about that only. So what this startup did was, sir, they basically developed a blockchain-based scenario solution, and they actually developed a device which they fitted in the review mirror of the car, right? Okay. Now this device is basically a 2G, 3G, 4G, and LoRa compatible device. And this device has an audio video capability embed. So it is a camera embed into it, and there is a microphone also, a very strong microphone embedded into it. And along in the car, like in the seat, in the top roof or side panels, they have put something called as panic buttons. Okay, they have embedded panic buttons. So the moment there is somebody is trying to forcibly stop the car or trying to actually force himself on the people inside the car, the passengers can reach out to one of those panic buttons. The moment the panic button is pressed, what happens is the device in the review mirror actually gets activated and it starts streaming the audio video which is happening inside the car to a backend server. Now this streaming is basically happening to two places in the backend server. One is on the startup's server where it is getting stored on a blockchain database, blockchain based ledger. And two is it is also getting streamed on a police control room server. So now since the device is 2G, 3G, 4G LoRa capable, so it will actually work even in adverse network conditions where there is absolutely worst network or no network, right? Now the device latitude, longitudes are basically being picked up by the police control room, and it identifies the nearest PCR WAN based upon the latitude, longitude of the device. And then it actually sends a SOS to the nearest PCR van to go to that location where the car is being subjected to whatever is happening inside the car. And in parallel, what is happening is there is a ticket getting created on the police server with the timestamp when the request came in, with the device ID, the latitude, longitude of the device which is streaming in, so that police can no longer come back and say that they did not get the information about this incident. And at the back end, the entire video of whatever is happening inside the car is also getting stored on a blockchain ledger. Why it is stored on a blockchain ledger? So that
So participants, I think there is some issue at Dr. Mani Madhukar's side. So we are just getting in touch with him. So please be patient.
am I audible, guys?
Yes, sir, you are audible now.
No, I'm not sure where did I got dropped off. I was actually asking Dr. Chintan whether he got his answer or not. This is where I remember I was talking.
Sure, sir. Dr. Chintan,
Dr. Chintan, did you get the complete answer, or did we lose on something?
Yes, sir. Yes, get the complete answer. Yeah, thank you very much for that.
Sure, thank you.
Thank you.
Guys, I missed the entire chat, so in case there is any other question
Yes,
in the
sir.
chat.
Yes, sir. There are a couple of questions. Sanjeev Bora wants to know what are the specific research areas in blockchain?
Okay, so as far as research areas is concerned, blockchain is still very nascent in terms of, maturing of various technologies to integrate. So right now, what we see is the transaction capacity, right, per second of a blockchain-based system is something which is of concern for us. So far with Fabric, we have been able to achieve, I guess, 1,000 or around 8,000, something like that, transactions per second capacity. But if blockchain has to be adopted in, let's say, stock exchanges or some other places where it's a very good use case to be, but then the transaction volume is like millions of transactions per second. Right. So in such places, blockchain is still not a good fit, or rather, blockchain hasn't matured to that stage yet where it can be implemented. So this is one area where there's a lot of scope of work. And if you do some quality work, maybe companies are willing to buy and sponsor your research. Similarly, in terms of cryptography, there is a lot of availability, scope of research there, right? Because we are saying that the entire ledger is basically available with all the network participants, right? Now, how do you effectively control that access is going to be very key for this technology to be, utilized globally. Why? Because on a blockchain network, you will have competitors also sort of joining, right, in terms of enhancing the business value. Now, when that is the case, then you will definitely want, some information to stay safe from the competitor, because you don't want everything to be made available to your business competitor. So a lot of a scope in terms of, there are already mature technologies available, but then there's still a lot of scope of work there. So, and then there are a lot of, consensus mechanisms are still evolving, right? So we just talked about proof of stake, proof of work, PBFT, POET and all. And there can be so many more consensus mechanisms which can evolve, depending upon the typical use cases. So that is something which is still open for researchers to work on. And then there can be so many more even. Hope that answers the question.
Yes, sir, sure. And one more question is there, sir. How blockchain prevents double spending? Sandeep Kumar Roy wants to know.
So that's when we talked about that version number, Sandeep, if you remember, right? So we said the blockchain is very effective in terms of controlling a double spend. So let me give you an example, right? So let's say Dr. Aruna has a car, okay, and she wants to sell her car, and I want to buy her second-hand car. Let's say this is an example, right? So what happens is the client application is sending a request to the endorser node. What is the request comprising? Saying that current owner is equal to Dr. Aruna, new owner is equal to Dr. Mani, and version number is equal to 2. 2 means this is the second time that the asset is car here. This is the second time that the car is changing ownership, getting ownership changed. Now what happens is somebody offers Dr. Aruna a better value than what I am offering, right? So, maybe, Dr. Aruna sells the same car to Dr. Chintan, right? Let's say for a better value. It's trying to sell the same car, let's say, right? So again, the same request has been forwarded to an endorser. Now what happens there is, the version number remains the same. Okay. Now by the time this request goes to the endorsement, to the ordering node, to the committer node, the version number which is already committed is 2, because one of the 2 transactions which you have got earlier in the pipeline got executed first. So when this new request comes with the same version number, then the committer will get to know that the same asset is being trying to double spend, right? So the same car is being sold to 2 people, right? And hence the last value or the last request will get invalidated, or it will be an illegal request. Similarly, it is for other requests also, right? So the version number is a key which helps in, double spending here, which helps in stopping or double spending over here. Hope that answers your question, Sandeep. Yes, sir.
Sir, one last question for now is, Shashwat Sharma wants to know which programming language is most helpful in blockchain.
So if you're working with a Hyperledger Fabric, then Golang is the go-to language. Golang should be the one, right? And it depends upon various blockchain platform. If you're working on Ethereum, Solidity is your language to go to, right? But then from an enterprise adoption point of view, Hyperledger Fabric is more suited platform, and you need to have skills either in Golang, or there is SDK available for Java. There is a SDK available for Node.js also, in which you can develop your client applications. So one of these languages you need to be frequent with in order to, work and develop blockchain applications.
Thank you, sir.
Any other questions around the chat?
Sir, I want to say 2 minutes, sir.
Sir, tell me, Pratap.
Yes. Yes, please.
Sir, I want to first happy Teachers Day, sir.
Thank you, sir. Yeah, we can hear you, sir.
Can you hear me, sir?
Thank you.
Yeah, sure. Please go ahead.
Okay, sir. Sir, actually, I want to thank to NIT Jalandhar, sir, because they are conducting online webinars like this short-term course also. So, till from Jalandhar only, I achieved around 10 certificates, sir, short-term course and FTP programs and all. So, till now I achieved around 300 certificates on the online one-day webinar, Coursera from the online certificates and all. And FTP program, I attended some quiz also. So all because of the teachers and organizers, speakers. So I want to thanks to all for motivating me and sharing the knowledge for me.
Thank you, sir.
So,
Thank you.
and also, my teacher is my last mistake. Said by Dr. APJ Abdul Kalam, sir.
Thank you, sir. Thank you.
So,
Yes, sir. Please, Mani, sir, continue.
Okay, so I have got, I wanted to share one more thing before I end up. Now, for those of you who are interested in getting more skills or getting deeper skills, I have something more to share with you. Okay, now IBM recently launched a program. It's a global program again, which got launched globally in December of 2019, and in India this program got launched in second quarter of 2020. This program is called Skills Academy. Okay, now I'll quickly take some 10 minutes of you to take you through this, and in case you are interested, so you can take down this URL, the skillsacademy.mylearnerportal.com. Okay, so this program is actually aimed at developing deep technology skills for both faculty and students, right? Why so? Because this is one of the infographics from World Economic Forum survey, which talks about that 54% of existing employee needs significant reskilling and upskilling, and this has become even more relevant because of COVID pandemic, right? This is even so much more important now. Now, this particular program looks at building digital practitioners. Now, what is a digital practitioner? Practitioner is somebody who can practice, who can deliver, who can do things, right? So that's the reason this program is actually a combination of lectures plus lab exercises plus group works, right? So almost 30%, 35% of lab exercises are there, 30% of theory content is there, and then another 30% of group work is there, right? This tech program is offered across 8 technology areas: IoT, cloud computing, data science, blockchain, AI, cybersecurity, design thinking, and quantum computing, right? So these courses are like 75-80 hours of online courses, guys, which are offered in the Skills Academy. And these are there, and what we get is we get badges after completion of these courses. Okay, so these courses are offered in 2 ways. Normally, the delivery is in 2 ways. One is the colleges nominate their faculty members, and we train the faculty members in one or more of these technology areas without any charges. Okay. Once the faculty is trained, they actually teach their own set of students. Okay, with at their own pace. We offer them the entire content to do that. This is not free, by the way. This comes at a small token price of some 3,000 plus taxes, okay, per person. But which is not payable for faculty members, but then it's for students, it is like 3,000 plus taxes. If their faculty is teaching them. If it is to be taught from somebody from IBM, then the cost is even more, but then we're not getting into that. So the ideal model that we want is the faculties get themselves trained in these areas, and from there they keep teaching their students in one or more of these areas, right? And once the faculty is actually trained, so I will tell how it is being trained. The faculty actually gets a instructor badge once they are trained. So for example, if a faculty is getting trained on AI, they basically achieve this instructor badge, which basically allows them to teach the content. Okay. Once they get this badge, then they can go back and they can actually teach their students. Once the student obtains, the course and goes through it, this is what the student gets: a practitioner badge. Each course comprises a mandatory module on design thinking. So this is one thing which people are not very much aware of. Developing a solution is not just coding. Developing a solution actually starts a lot more earlier than when you actually get to code. So that is where the design thinking comes into play, and sort of gets you in a mode where you start thinking that how do you create a solution? What are the features that should be put in a solution, right? So that is a design thinking. So eventually, anybody will actually get 2 badges out of this program. One is a design thinking badge, which is a mandatory module, and other is a technology practitioner badge. For example, if it's AI, then AI badge, or if it is a blockchain, then a blockchain practitioner badge, like that. Now, you can actually connect with me on LinkedIn if you want to get more details about it. right? If you want to know more about what these courses are, this is the link to know more about this. I'll just go back to the start of the slide where the link is available. You can take a snapshot of that. Okay, this is the link at the bottom of the screen where you can find more details about this program. You can always reach out to me on LinkedIn and you can get more details about it. Again, I would like to reiterate, this is aimed towards developing deep technical skills. So whether it's data science or it is AI or it is blockchain, you will be developing, you'll be working on a lot of labs, you'll be developing some solutions, some projects you'll be doing as a part of this. A lot of learning will happen, in these courses. So with this, I will stop here. And again, if there are any questions, feel free to, unmute yourself, ask the questions, or you can, put it on a chat, or you can, put it to, over a LinkedIn to me, whatever works good for you.
Thank you, sir. Thank you very much. So, dear participants, do you have any questions?
Any queries from the participant?
I think there are no queries. So thank you very much, Dr. Mani, for your very insightful session on this blockchain, and I hope our participants will be benefited from the knowledge you shared these slides, and particularly the research and researchers doing PhDs or MTech thesis in these areas will have most to take out from this session. So I now over to some of the questions, please.
Thank you once again, sir, for your knowledgeable session, and I hope all the participants are really enjoying your session. So thank you, sir, for accepting our invitation. Thank you.
Thank you, ma'am. Thank you, guys. It was really a pleasure to talk to you. Wish you all a great day. Thank you.
Thank you, sir. So, dear participants, now we are starting our valedictory ceremony. So, respected Professor L.K. Avasthi, Director NIT Jalandhar, Professor Mani Madhukar, Professor A.R. Saingal, Head of Department, Professor Harsh Kumar Verma, Head Computer Center, Dr. Geeta Sikka, Associate Dean, Faculty Welfare, Dr. Prashant, faculty members, and dear participants, I wholeheartedly welcome you all in this valedictory ceremony of online STC on security and privacy challenges in computing paradigms. I thank Professor Avasthi sir for guiding us and supporting us throughout the journey. Thank you, Professor Harsh Kumar Verma and Dr. Geeta Sikka for showing the right path always. Thank you, participants, for attending with such a zeal and eagerness. Now, I will present the course summary. So, on the first day, we have Dr. Manoj Mishra. He is from IIT Roorkee, and he shared with an insightful talk on the topic cyber crimes, network forensic, and identification of hosts behind net. And in this informative session, he discussed about the importance of cyber security as well as how to protect our network from cyber attacks, various fields of digital forensic and digital process framework. So these are also elaborated by him, and also he discussed about the working of the tools for capturing, analysis and visualization of traffic in network forensic analysis. Now in session 2, we have the Dr. Professor Pilli Mlaikar Shubhankar from the Department of Computer Science and Engineering at Malviya National Institute of Technology, and he shared his talk on security in blockchain. And he commenced the session from why we require blocks by explaining the concept of Bitcoin, its gaining value, why Bitcoin matters, and also demonstrated the live demo on blockchain to introduce the idea of blockchain concept. And he concluded his session by discussing the blockchain platforms which allow the development of blockchain-based applications such as Ethereum, Hyperledger, R3, Ripple, and EOS. Now on the second day, the session 1, Professor Sanjeev Sopat from PAC Chandigarh delivered his talk on cyber security complete framework, and in this session he discussed about the security goals, elements of cyber security and general data protections rules. And he also discussed the application security measures to prevent against the security vulnerabilities, and also shared the importance of database security to handle the threats. Now on the day 2, session 2, Dr. Narottam Chand, we have Associate Professor from the Department of Computer Science Engineering from NIT Hamirpur, and he delivered his talk on securing wireless and mobile data. And he commenced his talk with why the security by explaining CIE trad of security fundamental, its connectivity and service devices associated, and also discussed the current IoT communication technologies based smart home, smart campus and smart city design benefits and issues. Now on the day 3rd, in session 1, Dr. Durga Toshinwal from IIT Roorkee illustrate the significant concern about the privacy preservation for data mining and analysis. And she also explained the privacy in terms of legal and commercial concern that may prevent the parties from directly sharing some sensitive data. Now in the day 3, session 2, Dr. T.P. Sharma, Associate Professor from Department of Computer Science Engineering from NIT Hamirpur, expressed his view in expert talk on the most challenging area, coordination and agreement. Now on the day 4, session 1, Dr. Maninder Singh from Thapar University expressed his view in expert talk on the most challenging area, cybersecurity, and he covered the various technical aspects of network security paradigms and also discussed the concept of phishing attacks as well as some existing defense mechanisms, and also cleared the concept of the various cyber security solutions. Now on the day 4, session 2, we have the Dr. Naveen Chauhan, and his expert talk was on importance of security and privacy in Internet of Healthcare Things. And he also explained the security requirements in IoT-enabled healthcare and security challenges of IOST. Now on the day 5, that is Dr. Mani Madhukar. So we have already covered this session now. Now I would like to invite 2 or 3 participants to kindly give their views about the STC. Please. Yes, participant. Please share your views about this STC.
Wonderful learning experience. Should arrange more like this. It should be great for learning.
Okay, thank you, sir.
Thank you.
Yes, Palasha Gupta.
Good afternoon, ma'am. I am a student of MSc Cyber Security from IDVV Jabalpur. So this short-term course was considered a lot beneficial for me actually in IoT, artificial intelligence, and especially first session was very beneficial for me. So thanks a lot for arranging such sessions for us, and awaited for future further more sessions. Thanks a lot, ma'am.
Thanks, Palasha. Yes.
Good afternoon, madam.
Yes, sir.
Good afternoon, madam. Truly, it was a really great experience from last 5 days, because different eminent faculties took the lectures in a different areas, and they have shared their expertise. So we really benefited from that. Of course, that I believe that in particular research area, maybe there are a number of students are there and faculty also there. So there are a lot of different topic also they need to be discussed as well as explored in that manner. So I am really thankful to the whole team of the arranging this particular STC, and I am already put my suggestion in the feedback form also, that it is also a good idea to be any topic of AI or a blockchain or any cyber security related, so you can arrange on that 3 or 4 days or whatever days that it will cover more, and it will give a depth in that subject. So it will be more helpful to the faculty as well as the students. So again, thank you very much all of you for arranging such a wonderful STC. Thank you once again, all of you.
Thank you, sir, for praising our session. Any other participant?
Yes, good morning, ma'am. And good morning, sir. And happy Teachers' Day to both of you.
Happy Teachers Day to all.
Yeah, I am really thankful for Jalandhar organizing this coursework and enlightening us on the all the global IT trends. And thank you so much for this coursework.
Thank you, participant. Now, I would like to invite Dr. Harsh Kumar Verma, sir, to present the vote of thanks.
Honorable Director, Professor L.K. Avasthi, Professor S.T. Mishra, Registrar of the Institute, and coordinators Dr. Aruna Malik, Dr. Prashant, Dr. Geeta Sikka, and dear participants. It has been a marathon activity last 5 days. As Dr. Aruna told, many eminent speakers were invited and they have delivered reasonably expert talks to your satisfaction. Participants have already said that they are satisfied with the course. So our purpose is done. So I'm on the onset, I'll thank first of all our director, Professor L.K. Avasthi, who has been motivating us from time to time to organize such events. So this is one event in the series of those events. I'm also thankful to our Dean R&C, Professor Sinha, and Registrar of the Institute, S.K. Mishra, for giving us all the support. And I'm also thankful to coordinators, Dr. Geeta Sikka, Dr. Prashant, and Dr. Aruna Malik, for making all the efforts to conduct this course. Finally, I will not forget all the eminent speakers who have really acceded to our request, especially busiest professors, some like Professor Manoj Mishra, Dr. Durga Toshniwal, Professor Sunil Joshi, Professor Nautam Chand, and T.P. Sharma. Finally, today we had Mani Madhukar, and many other eminent speakers were invited. So I'll thank all of them to be part of this course, and who made it to deliver a talk on this course and made this course a success. So I'm also thankful to, I will not forget all the participants who have been attending the course patiently and learning through this 5 days activity. So it is both way, only speakers cannot make a course success. It is the participants who make the course success. So again, I thank everybody for being part of this course and hope to meet you again. We'll conduct such courses again from time to time. Now, I'm thankful to all of you. Thank you very much.
Thank you, sir, for your words. Now we just come to the end of this valedictory ceremony and also the end of this 5 days STC. And we sincerely hope that all the participants will definitely get benefited from this STC. So I just want to again thanks to all the participants and all the members. Thank you once and all. Thank you very much.
Thank you, sir. Thank you, madam. Thank you, one and all.
Thank you.
Once again, thank you all of you. Thank you, managing committee, and thank you, madam.
Thank you, doctor.
Sir, may I ask you about the certificate, because I haven't received it till yet on my email.
You didn't receive because we didn't send it yet. And please allow us some times. We have just wrap up the things, and now we will collect your attendance, and all the participants having 80 plus attendance and submitting these feedback, all will get the certificate within a week. So please allow us some time. We'll send it to you.
Sorry.
We will definitely posting the e-certificate on your registered email ID, so don't worry about that.
Sorry,
Please,
ma'am.
please don't forget to share your feedbacks in the link.
The link is given to in your chat box, so you just refer that to feedback link, okay? And after filling that, we will definitely give the your certificates to you. We will issue the certificate.
So only one feedback is given, right?
Yes.
Okay, and that STC we have provided the one link.
Okay, because so many links is available, I got confused. Right.
No.
Only feedback.
There is a same link. I am just pasting it again and again. Sometimes connection.
Sir, if you don't mistake, can you tell your name, sir, please?
Dr. Prashant.
Dr. Prasad, sir, shall I tell one thing, sir? Sir,
Sure.
Still now I have attended the last 4.5 months or 5 months. I have attended so many FTPs and so many things. And today only I am seeing such a patient, wonderful person in answering all the questions. You are two patients, right? So really I want to tell this thing.
Thank you, sir. Thank you.
Yeah. So thank you, sir. Thank you so much.
Thank you, participants. Thank you.